Scan is also a Dixit-Tooling algorithm. In this question, we have to find out the average seq length using scan algorithm with 200 tracks, and also the queue length is given, and the ready queue length starting from the value is 87, 170, 40, 150, 36, 72, 66 and 15, as well as the head, that is the starting head, is also given. The value of the starting head is 60. Okay, here we draw the total disk track. According to question, total disk track length is 200. For that reason, it's starting from 0 and cover up to 199. Okay, now in this algorithm, when we consider the starting head is 60, we find out the nearest value of 60. So in this ready queue, the nearest value of 60 is 66, right? So up to this, algorithm is similar to as SSTF algorithm, but another important thing is added in this algorithm, that when we consider the nearest value, then it move to the only one direction. Okay, when we move in one direction, at that position it cover up to the last value of that direction, then move to the another direction. Okay, let's see. So the starting head is 60, that's why starting point is 60. Then according to step 1, it find out the nearest value. So the 66 is the nearest value of 60. This is the point of 66, and we find out the head movement. So the head movement is 62, 66, and the gap is 6. Again we find out the next nearest value of 66. So next nearest value of 66 is 72. Here we draw the 72 point. So the next movement 66 to 72, again the gap is 6. Next nearest value of 72 is 87, and again we calculate the head movement, that is the movement is 72 to 87, so the gap is 15. Next nearest value of 87 is 150. So again we calculate the head movement, 87 to 150, so the value. Now the question comes in our mind is, the nearest value of 87 is 40, but here we consider the nearest value of 87 is 150, because according to scan algorithm we have to consider only the one direction value, that is the step 2. At first step 1 we consider the nearest value of head. Next, when the movement is starting from one direction, it move to the last position or the last value position of this direction. That's why we have to choose 150 value, not 40. Okay, so the next nearest value of 150 is 170. Again we calculate the movement, that is 150 to 170, so the value is 20, and the another or final head movement is 170 to the last position, that is 199, and calculate the movement, that is 170 to 199, the value is 29. Now up to this direction all the values are completed. Then we move to the another direction. Now in that case we move to the last nearest value of 199. So what is the last nearest value? That is 40. That's why here we draw the margin up to 40 and calculate the movement, that is 199 to 40, and the value is 159. Again we find out the next nearest value of 40, that is the value is 36, right? We draw the value 36 and calculate the head movement, that is 40 to 36, the value is 4, and the last head movement or the remaining value is 15. That's why here we draw the value is 15 and calculate the head movement value, that is 36 to 15. So the value is 21. Up to this total ready queue values are completed. Okay, then find out the average seek length. So at first we have to total all this value, next divide on the movement value. So the total value is 323, and when we calculate the average seek length, at that time we have to divide on this total movement, that is 1 2 3 4 5 6 7 8 9. So the total movement is 9 and the value is 35.8 and the unit is cylinder. Okay, so this is the head movement using scan algorithm.